How you doing, everybody? Randy Richard in the shop, and this video is the starting of a new project. It's going to be several parts. There's a lot of parts to make, and what I'm going to do is show you in Fusion the model and explain that from here. So here's the welding table. Here's the welding table I had ground, the plate modeled up, and on the bottom, if you've seen in a previous video, I had a bracket attached to it. Now this bracket and the stand part of it came from an old satellite dish, so it had the hole and the pivot, and it just kind of worked out just right. So this is bolted to the bottom of the plate. And then the base I made looks about like this, and this is a brake drum from semi tractor trailer, very big and heavy cast iron drum. And this is just a piece of scrap, 1/2 inch thick, 4 inches wide, flat bar hot rolled steel. And then this is the post and the bracket that came off the satellite dish. Now this hole was existing on this hole I put in. So this is what I'm going to make, is this arrangement here, because so this table, we'll turn it here, so this table will flip this way, right? And I need to be able to control that, or hold, if I want to hold it at an angle, if I'm working on something on one side and you want to flip it over, you can just flip the whole thing over. It's if you have it attached. It's adding versatility to the platform here, the welding table. And this is what I'm going to make here. Here, we'll back up. And you'll see here how this operates. You'll be able to, we'll go back over here. You'll be able to lock it in any position from vertical here to vertical here, without having to do too much to do that. So the top part is basically, there we go. The top part is just a block with a pin, and we'll expand that a little bit here just so you can see it. Let me put my glasses on now. We'll just kind of back up and show you. There we go. There's the block I need to make. We'll have a couple of counter bores for bolts that will hold it on, and those will go in there like so. 3/8/16 socket head cap screws, and they will not go through the table. We'll just drill in about 3/4 of an inch through into the table, and then we'll have a pivot pin that will be pressed in right there. And then there'll be a pivot, of course, that goes on here, and then a retaining washer and socket head cap screw just to hold that on there so it slips on easily. And then there'll be a bar. Now that bar will be welded into the pivot from this side here. So that bar will be welded in here at this point. Then we have the bottom part of this. Now the bottom part will act like a large snug you use on your dial indicator stands and things like that. So this will just operate just like a snug, where if you turn this over here, this end over here, it will tighten it and clamp it. And just a quick little quarter turn loosen in it will allow this to slide easily and then be locked in any other position. So it's really kind of basic. The bottom slide, we'll show you that real quick. So basically, this is just a tube here, and inside will be two ball bearings, one on each end, just to make it spin really nice. And then we'll have a little here. Then we'll have a plug that will have a threaded drawbar, so that plug will be drawn with a drawbar, and then the hand wheel nut or on this side, which you'll tighten to draw it tight, and then over this you'll have a sleeve that will be drawn. This will be pressing against the tube, and then you'll draw your drawbar and hold it all tight. And let's see here. Let me back up here. We'll the hand wheel there, and I'll put the bearings in. See, there's a bearing inside there, one on each end, and then the hand wheel, and then some type of lever arrangement. I haven't decided on the handle situation exactly yet, but this should work out pretty good. We have freedom and we have clearances, and that happens every once in a while when the computer doesn't want to cooperate. It'll throw that out there, and there we go. We'll get it to go back. Anyway, so we can get any position. So we have about 10 parts to make, and we're going to start with the block up here and get this pivot built, and then we'll move on to building the lower one and then installing, of course. Now the tube here will be welded to this column once we have this all positioned and in place. And that's going to be the welding table. And I'm going to have one other modification, or no, not a modification, an add-on to it after we get this done. So we'll start right off building the block, and I think we'll be good. So I hope I don't know if you like this format of doing something like that on Fusion, but it's kind of a easy way for me to film it actually, and I think we got some good video and good sound to it. So let me know how you think about that, and we'll go on from there.
Actually 10 parts to this angle adjusting mechanism I need to make. First part's going to be this block. Precision hole in the center there, and 2 bolt holes, countersunk bolt holes. This is a sawed off piece of hot rolled steel. It's 1 inch thick by 3 by about 1 3/4. This is a sawed in. I just hit it with the belt sander real quick just to get it kind of remnants of something kind of flat. I marked 2 edges I just chose a side and a bottom as a reference. We're going to square this block up. Take that one down and that one against the jaw on a very short parallel to get it up. Just one parallel. We're going to put a piece of aluminum wire, actually a piece of welding wire in there, tight. We're going to mill off the top first. Just finding the high spots. There's a high-speed end mill, Niagara, roughing end mill, 3/4 inch. I want to take off pretty much minimum material, so we're just going to take it easy here. Looks pretty good. The actual dimensions of this, as far as its physical dimensions, aren't real critical. It's more about the precision of hole and the bolt holes. Okay. Now this will end up being our starting reference side, since we got something going, and still the back side. So there's several ways to do all this. This is just a kind of a quick and dirty way. So it's not like the necessarily the best or the worst way, right? Now we're going to make this side. Now that X side stays against the jaw. Looks good. We'll do a quick check just to see if that's pretty parallel. 1685. 1685. Pretty good. Good enough, let's put it that way. Remark our X's just to make sure. All right. Now I want to maintain this side, the same X side, against the jaw, and I'm going to do these other ends. I'm going to use a parallel in there just to get it up off the bottom. Use one of my bar Z squares to set this somewhat square. Now we'll dust off this end. All right, deburred, and just a quick check on this is our bottom edge, and these are our reference sides. And just a quick check, and there's no light. That's pretty good. It's good enough for what we're doing here. Now we're just going to flip this over and use that, and use our X side against the jaw. Deburr. Now we're going to check that, make sure that's square, and that looks just no light. So that looks pretty good. I'm really happy with how that's all coming out. Yeah, now we only have the two sides to do. So we'll use our two references again. The reference here, one will be against there, and we'll put the X one down on some parallels. This came out pretty good. This one side I'm a little off though on my parallel, so I must not have been real good tight when I did that. This side's good here, but this one side isn't flat, right, or isn't square to the same side as this one is. You can see there, so we're not square going around this way. Otherwise, we're really pretty darn good going around this side. This way we're good. But I got off a little bit going around this way. I shouldn't have been off that much. Anyway, so I think I'm going to put a finishing end mill now. That this is just a roughing end mill, so it's not the perfect finish or anything. I should have done this probably with a fly cutter, but just for tramming wise, we're really good. There's no perceptible seam or between the cuts at all, so that's pretty good. Maybe I'll put a finishing end mill in and just do a few light cuts and fix that. Doing some just quick checks here where the square and get the chips out of here. This side to the big flat side is pretty good, and this side to the other side too is pretty good. So actually these two sides aren't too bad as far as parallel goes. It's this side and this side are not this side and this side aren't square to one another or parallel to one another exactly. So what I really need to do is this edge, this side here, which is off. When you do this, it's a bit of a gap there. You can see that, and then this side also with both sides. So this is the side that's out, and I'm going to put it up in there and on a parallel again, and we'll give that dusting. So I have a 1/2 inch carbide end mill in here that's very sharp, and we'll just figure out where high is there. That's a finishing type end mill there, and that is awesome. Actually, just awesome. Came out beautiful. Let's see how the squareness is now. Oh, that's perfect. Perfect. That's what we want. Just perfect. So we're good and square now. Just that one side was a little off. My moaning grinder, well, deburring wire wheel. Anyway, we're good here. We can continue on. Let's get our drill holes, I think, in there next. So here's our block we just did. These marks indicated the side that I thought was pretty good. As far as squareness goes, so I could mill the side that was really bad, right? So this is our really smooth, really nice side. We're going to do a real quick, just a quick check on some parallel and squareness real fast here. Now, there's only really, I should say, three sides of this are really kind of what I want to be kind of pretty close or fairly good. So I want one of these long edges here to be good. That's this one. So we're going to choose that one, I should say. And I want this side to be parallel and square to this side. So these three sides are the ones I want, to be good. The rest really won't matter. It won't matter at all. So, but we're gonna check them anyway, just to see how we did and such. So let's. I'm kind of set up here to check up parallel. So we're just gonna put one side down. It's clean. Plate's clean. So I have this. I'm just gonna choose that black mark on there, and we have it set at 0. And I'm just going to sweep around this here. Now, this is a rough surface, so the needle moves an awful lot, but that's, less than a half of there, half there. That's 0, about 0, 0, 0. Less than half, a few tenths there. Like I said, that's about 0. So, we're really parallel. The two sides are very parallel, which is really pretty good, which is nice. For the mill, that's excellent. Now, we're going to put this real nice side, our finished side, we're going to put it down on the plate. And I'm going to set it up. All right, now I'm set up to against my radius here on my tool, on my surface gauge, and the needle here with about half of a dial deflection, and we'll maybe a little bit more. Anyway, we're just going to sweep it. We're just sweeping back and forth, and I have it pretty much set at 0. Now remember that surface is rough, so it's pretty close to 0. So then we're going to just turn the block around and check this side. Now I have the bad side down, the side that's not necessarily square too good, and we're going to check there, and it looks like we're about 3.5 thousandths out a square there between the two. So that's 1.5 thousandths per side basically. Now I'm going to turn it over, put our real good side down, and we're going to zero out here on one spot. Oh, there, it's pretty good. Or let's see here. Make sure we're find our high spot. Put a little off. There, that's pretty good. 0. And I will spin the block around and check it this way. And we're, how much are we at? 1.5 thou. About 1.5 total thousandths off. Well, right now it says 1. Yeah, 1 thou. So we're only about a half a thou out a square. from this side. So this side we're about a thousandth and a half out a square per side, and here we're only half a thousandth. So that's for doing this stuff on the mill, that's pretty darn good. I did not. We didn't check the ends. I didn't really check them, but let's see here. We'll zero this end. Yeah, it's pretty close. And we'll swing it around. We'll check this end. So the ends are out a bit. So they're 6, 7, about 7 thousandths out. So 3.5 thousandths out a square with this side here. So I'm okay with that. These ends mean absolutely nothing. So 3.5 thousandths is no big deal. But I could probably make it better if I went over to the mill and took more care and more patient with it and used that finishing end mill on there. I would end up with that probably squarer for sure. So not too bad. Let's go over and put some holes in. All right, we've got our zeros. We're going to put a 3/8 clearance hole, and we're going to counter bore a couple holes. Pretty good. Looks good. I'll just quickly deburr those by hand. And we're going to put a precision hole in here, which a pin is going to press into actually. Little smoky. I didn't feel like getting the anchor lube out. This hole here, I would like to be 0.899. Now, I'm going to make the pin that goes in it. So, you know, plus or minus 1. I'm going to shoot 4 on that. I'm using actually a Bokum boring bar inside the 2-inch Criterion boring head here. So this is a high-speed steel boring bar. So we got to take it a little bit easy. I drilled that 3/4 of an inch the hole. All right, we need to take off 138 thousandths on the diameter, so we'll just do I don't know, maybe 20. I'm going to try 20 here. All right, that was good. That took off exactly 20. What you want to watch, make sure you watch that. We'll go 30 this time. I took off exactly 30, man. No spring at all, so that's sweet. All right, I just measured this, and I have just a couple tenths of taper, which is kind of normal. As you get down in a hole, a lot of times that's what will happen. You know, it'll be a little bigger on the top and a little smaller on the bottom. But it's just a couple tenths, so I'm not doing any spring passes. All right, so I need about 28 to go. So I'm going to take a 10, and then I'm going to do a 20 for my final cut, because that 20 sure gave a nice finish and everything. So we'll just do this and remeasure. Being hot rolled steel, it's you don't get the finest finishes. Just making sure my tool is clean. Okay, that worked out really well because we're right at 18,000. So take 18. That's the kind of chips it's was making, these little fine stringy chips. Cutting really nice. So I was shooting 4.899. Now, okay, I'm getting 8996, 8995. I'm going to measure that again. And now I got 8997. It's always good to do this several times, your measurements. 899, 898, 4, 899, 898, 0. I'll measure it farther down the hole and see what's down there. Because the surface isn't, perfect, but it's pretty good. 8978. So we're looking probably around 898 is pretty good average. So the pin I make will go in there. I'll make it so it's thousandths over this probably, and then and we'll press that in. I'll probably warm this up and then press it in, even make it a little easier. But I wanted to make a nice press fit. That way I won't have to weld it or anything. I think I can countersink that a little. I want to make sure on the one side I have a countersink, so the shoulder, that there's going to be a shoulder here, that it doesn't interfere with being seated all the way. Okay, I think we're done. That'll be perfect. Here we go. So that block came out just beautiful, and these two 3/8 cap screws or socket head cap screws will go in here, just like that, and they'll be bolting up to a plate.